binomial expansion for 1 plus x to the n, where n is not a positive integer, is given in the formula books. Sometimes it looks a little complicated, but essentially it is 1 plus nx plus n minus 1 over 2 factorial x squared plus n minus 1, n minus 2 over 3 factorial x cubed, and so on. The expansion can only be used when the constant term is 1, and is only valid when the x is between minus 1 and 1. This is to ensure that the later terms converge. So as an example, with 1 plus 3x to the half. So here n is equal to a half and the x is replaced by 3x. So we have 1 plus a half 3x plus a half minus a half times by 3x squared over 2 factorial plus a half minus a half minus 3 over 2 over 3 factorial, which I shall write as 3 times 2 because it will help me see how I can cancel factors from top and bottom, times by 3x all cubed. There are further terms that I haven't included. This then needs tidying up. And I'll put plus dot 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 to show that there are further terms, and the expansion is valid in this case when 3x is between minus 1 and 1, or when x is between minus a third and a third. Here's another example. So the first thing to note is that the constant term is not 1, and therefore I need to take out a factor of 2 to the half and rewrite the brackets as 1 minus x over 2 to the half. So I'm actually going to expand 1 minus x over 2 to the half. Here my n is a half and my x is minus x over 2. So it's 1 plus a half times by minus x over 2 plus a half minus a half over 2 times by minus x over 2 all squared plus a half minus a half minus 3 over 2 times by minus x over 2 cubed all over 3 factorial, which again I shall write as 3 times 2, and there are further terms which I haven't included, and then I can tidy this up. And this expansion is valid when minus x over 2 is between minus 1 over 1, but I'll write it as minus 1 is less than x over 2 is less than 1, or in other words when x is between minus 2 and 2.